Let's pick up where I left off, guys. I've got my third hand out here, and you can see here's the resistor board that I need to go ahead and swap out all the resistors and this one cap. So we've got 6 resistors, 1 cap, and a couple jumper wires here on the back side. So I'll go ahead and work this offline, come back and provide an update once I'm done. This resistor board, just like the other one, cleaned up really well. And I checked all the component values after getting everything soldered in, and took time to confirm the schematic that everything matches, and it does. So I think we're ready to get this installed. You will notice here that some of the terminal lugs broke off when I was desoldering in 3 different locations. But no big deal. You can see I've got the component leads protruding past that point, and I'll use the coil method, or I'll create a solder loop for the component, so that gives me some flexibility. Let's get this thing back in the chassis now and start doing the tie-in points. I did a quick dry fit here just to make certain I could squeeze my resistor network board back down in here. And I'll have to move some of my leads around, reform things. But first up, the standoff actually for the board is the IF coil in this wooden dowel former. So it's got to be mounted down here first on the chassis. I'm going to go ahead and take some time and redress these leads here with some new wire, study the schematic, and look back and see where these tie-in points are. But for sure, since the resistor board mounts on this, I've got to get this back in the chassis first. So let me study things up, go ahead and get these desoldered, then I'll recheck my DC resistance on the coil just to make certain I don't create any new issues. You can see this one's already taped up right here, and if that's showing up, you can see that lead coming across right here. So that's a little concerning. I'll exercise some additional caution there when I work around this area. In my third hand, you can see I've got one of the variable capacitors. These read maybe 113 to 125 picofarads, the way they're adjusted right now. I haven't cleaned this one. But I'm going to go ahead and take some time and desolder these old lead wires here and get those cleaned up and get it remounted to the chassis. And I'll be using it as C10, Charlie 10 is notated here on the schematic itself, and that will tie back in on the plate of the 6B7, and that will also be my tie-in to pin number 1 on that L3 coil. In addition, you can see it comes down and ties back into this part of the circuit down here. In one of the prior videos, I mentioned I had cleaned up one of these little variable capacitors or trimmers, and let me show you what I had to do. You can see these pop rivets here. They go all the way through, and the mica sheets are already attached and underneath that part of the assembly, so I can't get them out. So what I did was spray some cleaner down in here between the plates and the mica. And this design too, I think I stated there was 1 piece of mica. There's actually 2 pieces of mica that I can see. One that goes right up against the backer bakelite material, and then it looks like we have a plate followed by another piece of mica and then another plate. So I hope that's you guys are able to see a shot of that. I'll try to move it around just a little bit. I think I had mentioned earlier too, if anyone knows who made these, the manufacturer back in the day. Let me know. I didn't do any research, but I don't think I've ever worked on a radio that had this particular type of trimmer installed. It's a pretty cool design, actually. And you can see the little standoffs there between the chassis and the capacitor itself. For those that are new in the hobby, I'll try to explain this real quick. You can see I have my LCR meter hooked up. I'm looking at it in a capacitance value that was actually by auto or default. And you can see the capacitance value here indicated on the meter at about 58 picofarads, and you'll see that the plates are at maximum separation. So as I take the trimmer here and adjust it and compress the plates and bring them in closer together, you'll see the capacitance ramp up and go higher. And I think my starting point on this before I cleaned it was right at 200 picofarads. Now I'll probably get some stray capacitance because I'm holding this in my hand, so it's not going to be perfectly accurate. So it looks like the range of the capacitor, at least this one, is somewhere just north of 200 picofarads, and what did we say, it bottomed out at around 80 or maybe at 50. There we go, somewhere in that area. So we'll call it mid-50s up to around 200. Let me get this remounted in the chassis. You can see I have the little trimmer or the variable capacitor remounted into the chassis here. And we've got some nice clean solder lugs here to go to. I still need to dress up that L3 IF coil. Let me go ahead and do that and get it prepped and ready to be inserted right here. This makes me a little nervous here. You can see where that tape was placed here. You can see the wire coming off of the coil. The good thing is I can see it if it breaks, but it's interesting to try to understand why all this was taped up. Let me see if I can get it cut off here. Your guess is as good as mine why that tape was placed on there. I see no reason for it unless when this is mounted back in the chassis itself, something was making contact with this solder connection. So we'll have to look at it, but you can see I was able to cut it off there with a razor, and there's the lead itself coming off the coil. Let me get these other leads desoldered. We're not out of danger yet. And go ahead and get some new lead wires attached, and then we'll check DC resistance and compare it to our previous recorded results. I've got that cleaned off well, best I can tell, and I see just a little shiny magnet wire there, and it is twisted back around the lug. And as you can see here, I'm going to use some of my pushback wiring. And if you reference the schematic itself, it shows this should be a white lead leaving this part of the coil, and it attaches itself back to the volume control. Let me go ahead and get this soldered up, and then we'll go ahead and check after I solder and just make sure electrically we're still good between this point and the other side of the circuit. With that solder connection here complete, just the one, I wanted to go ahead and check back and make certain that we're still good, and this matches my existing readings. So you can see right there 47, 48 microhenries and 4.1 to 4.2 DC ohms of resistance. We're halfway home and we're still good. Alright, I got the other side of the coil complete with the new lead dressing, and everything checks great. I'm going to go back and double check this other side here just to make certain nothing has changed, and just do a little cleanup first. And then one more check, and let's get the coil mounted back in the chassis itself. What a tight chassis. I finally got the coil back in here positioned up underneath the resistor board using the fastener and the wooden dowel that was part of the form factor for the coil. But everything has to be positioned exactly right, or you will have a short. And I think that's probably why that piece of tape was on that one coil lead. But I think I've got everything now nice and tight, and I've got everything positioned where the coil itself on the primary and secondary appears to be free from the resistor network board, and the connections on the coil itself, best I can tell right now, appear to be free from the chassis. So I'm going to do some DC resistance measurement checks just to make certain that I don't have anything contacting each other. And then up next, we'll go ahead and start getting this tied in. Just can't believe how tight this really is.